students, today's lesson is on comparing linear and nonlinear functions. So to start with, we have this key idea that the graph of a linear function shows a constant rate of change, meaning it makes a straight line. A nonlinear function does not have a constant rate of change, so its graph is not a line. So we'll look at some examples of each of these. In our first example, we're going to look at each table, a function represented by a table, and we want to know whether this function represents a linear or nonlinear function. So here we can see that x is increasing by 3, and as that happens, y is decreasing by 8. So that is a constant rate of change, with a slope of negative 8/3. So yes, that is a linear function. Here we see this next example. The x is increasing by 2 each time, and the y, here it increases by 9. Here it increases by 22. Here it increases by 55. So we can see that over time, the rate is increasing. So it's not at a constant rate of change. That rate is increasing over time. So this is not a linear function. Still a function, but not a linear function. All right, so let's compare some functions with graphs. So does each graph represent a linear or nonlinear function? So here we can see that we have this curve to our function. It's not a straight line. We can see it's increasing over time, but it's increasing at a great rate, and then that rate really slows down to 0 for a little bit, and then that rate increases. So no, this is a nonlinear function. And then our second example here, we can see we have a straight line, so this is a linear function. All right, let's look at our next example. We need to decide which function is nonlinear. So we can think about our slope-intercept form of a line, and y equals 4.7. That would be a straight line where y is always 4.7, a horizontal line, so that is linear. Here we have y equals pi times x. So we can think of this as like y equals mx, where the slope happens to be pi. It's kind of a strange number to have as a slope, but it is a constant number. So that is a linear function. This function, we could distribute that 4 and get y equals 4x minus 4. So that is a linear function as well. We can picture what that looks like. This last example, though, over here, see, we have y equals 4 divided by x. That's not going to give us a straight line, right? It's undefined at x equals 0. At x equals 1, it's 4. At x equals 2, it's 1/2. At x equals 4, it's 1. So it is not a linear function. All right. Here we have a real-life application. So we have two different accounts. Account A earns simple interest, meaning it makes interest just on the principal that you've put in the bank. Account B earns compound interest, meaning it makes interest on your principal as well as the interest that you've already earned. So the table shows the balances for 5 years. I've already graphed the data for you, so you can just look at the graph on your notes and see that account B, you can see this curve to the line because that rate of change is not staying constant over time. It's increasing because you're making more money off of your account because you've already earned some interest on it. So while the interest rate might be the same, the amount that you have in your account is not linear because you're earning interest on money that you've made over time. So that would be both, if we want to compare the graphs, we can say that both accounts show balances that are increasing. Account A increases the same amount each year, where account B has different amounts. So account A shows a linear function, account B has a nonlinear function. All right, go ahead and try a few on your own. I'll see you soon.